this is still part of the law of sines. Okay, so it's really only with the law of sines that you have what is called the ambiguous case. There is one thing that, like, I'll mention in our notes tomorrow when we do law of cosines, where, like, you can choose unwisely in law of cosines when solving, and you can get, like, a triangle that mismatches, like the longest side isn't across from the longest angle, or the longest side isn't across from the largest angle. But that isn't, just because you get the like, mixed up numbers, that's not the same thing as the ambiguous case. So the ambiguous case with the law of sines, just to clarify the word ambiguous, different synonyms or things that we could use here, we're basically saying like unclear. This is a case where the given information, when presented to you, is unclear what it's going to do. Is it going to produce one triangle with that given information? With the given information, can you produce two triangles? Or even in some cases, triangles not possible. Okay? And just by looking at the numbers, we don't know. Okay? So it's not like we'll be able to just like see the problem and be like, oh yeah, that's two triangles. Oh yeah, that's zero triangles. There are, if you look in the textbook in 6-1, there are like a set of ratios, or not ratios, inequalities, or if you notice some things are greater than or less than, that you can determine what type of ambiguous case it is, but it is not friendly. Like, it is not easy to tell, or like it would be a lot of memorizing. So I'll teach you just to run through the steps and assume that there are two triangles, and if there are not, then the math will tell you so. So I just want to present to you, this is on GeoGebra, I want to present to you why the ambiguous case is what it is, how it's possible to have zero triangles, one triangle, or two triangle. So on the homework that you guys did for today, what I presented to you on Friday, you had cases of law of sines where you had, like, with the given information, you maybe had like angle, angle, side. So two angles and not the side in between the two angles. Or you had what we would call angle, side, angle, where you had the two angles and then you did know the side in between them. But in both of those cases, if you know two angles, you really know all three angles. Okay, so you don't necessarily know it right off the bat. We solved for it first, right? 180 minus the two angles, and then we knew all three. And so then we were guaranteed like the option of using law of sines, because across from that angle we would know a side, and we could set up that one ratio. The given information today is not going to be two angles and a side. It's going to be two sides and an angle. And there are basically two options for that. Side, angle, side, which we talked about like for using that area formula, where you know two sides and the included angle. But think about that drawing. If I knew these two sides and this included angle, I'm not going to be able to use the law of sines, because across from 30, I don't know what that side length is. Okay? So this is actually going to be tomorrow, side, angle, side. That's going to be law of cosines. The other option is side, side, angle, okay? Which, when you learned like triangle congruence postulates back in geometry, side, side, angle was not a congruence postulate. Like if you knew in two different triangles, like two pairs of sides were congruent and an angle not included in the sides were congruent, you did not know that they were actually congruent triangles. Did your geometry teacher ever tell you that you would never have the bad word? Reading it backwards? ASS? Okay. So it is not a congruence postulate for geometry. However, it is possible that there could be a triangle that exists, in terms of solving the triangle, given two sides and an angle that's not included in them. So that would be a picture, where like maybe I say this is 5 and 6 and this side over here is 30. Does the triangle exist? Okay, that's the question that we're going to be addressing. Okay, so what I'm going to tell you, different than what your geometry teacher said, is not that there never could be a bad word. There can be the bad word, right? And if you've always wanted to write bad word on your math paper, now is your moment. Okay, I won't even judge you. I mean, you have free reign here. Now on the board, I always write side angle. Okay, but if you're just feeling like you need to get something out, just go ahead. Free reign today, in this chapter. But the thing about that is the bad word, I tell my students, signals the bad case, meaning the ambiguous case. You don't know what's going to happen. So I like that bad, like if you think about that you have side angle, I like that it spells a bad word because it makes me think like, oh, I have to be really careful here. Okay, it makes it easier for me to know when that's going to happen. So on this GeoGebra file, I have the given information, 2 sides and an angle not included in the 2 sides. So I know that this side is 2.5. I know that this side is 3.5. And then I know this angle over here is 56. So I'm given side angle. Not the angle in between the 2 sides, but an angle like on the edge of either side. And then I have this like dotted line because to make the angle 56 degrees right here at B, it's going to have to extend out in that direction, right? And my other side of my triangle is going to have to meet up with it. Well, as I have this set up right now, you're seeing what's going to happen. Liam is shaking his head no. No triangle exists, right? If this is my side, I'm swinging, and I'm just like never going to close that triangle. It's never going to be a closed polygon shape. So sometimes your side across from that given angle can be too short, and then you have no triangle. Okay. Other times I'm going to change the length of this side. Let's see, that will be side B. So I'm going to change the length of that side. Other times, I'll stick at 4.3 and see what happens. Now it's past that line, so I just got to line it up, right? There's a triangle. I could actually close it, and I could have this side be 3.5, this side be 4.3. This would be an angle 56, and then I could go through and I could solve, like, what are my other 2 angles? What's my missing side? Let's see what happens. Oh, yeah. Looks like I only have 1, right? There's only one way for me to cross that line. Right about here. But if I keep going, it's like too long. Okay, everywhere else. Okay, so there's one place. And then if I can, let's see, get my length for B just right, side B over there. I didn't check it this morning, so what did I have it on before? 2.9? Is that too short? Okay, I could close it right there, right? Okay, so then I would like solve for this angle, solve for this angle, solve for this side. So there's a closed triangle. And then if I swing this around, well, that might be an example of just 1 still, right? Here, let me put my circle up. Like I'm swinging around that extra side. If my circle is just tangent to that side at 1 point, then I'm going to have 1 triangle, right? This will help me get one where I could get 2 triangles. Oop, not so big. That one was too big, so I could only get 1. Right about here. Okay. So notice it's pointing out the 2 places where it crosses that line. I could swing this side back, and I could create a triangle ABC right there. This triangle I would classify by angles as acute. All 3 angles appear to be less than 90. But if I swing this side over, there's another point right there where it's a very slim triangle, but it's still a closed shape with 3 sides. So it's also a triangle. If I were classifying this angle or this triangle by angles, I would call it, looks like obtuse. This angle right here now is more than 90 degrees, isn't it? So here's an example where if this side length is 3.2, I could potentially have 2 triangles that work. Okay. And that's because it's the side-side angle case, okay, which is the ambiguous case. So we're going to always assume this, that there are two triangles. If there are not two triangles, the math won't let us solve for a second one. And so we could say there's one triangle. And then if there's not even one triangle, the math will tell us there is not a triangle. So we're just going to kind of, if we see ambiguous case, let's assume there are two triangles. Okay, so let's go back to our notes and we'll do an example. And you'll want to have a calculator so you can calculate along with us. We're going to do angle B is 33 degrees, side A is 23, and side B is 14. For the purposes of notes, I am going to draw a picture. Okay. It would be up to you if you felt like you needed to draw the picture on a quiz or a test. You can tell that this one, you can use the law of sines right off the bat because you have angle B and side B. So that's going to be your pair for law of sines. Well, if I set up those two pieces that I know, right, 14 over sine 33, then what do I have to solve for first? Based on the other given information. I have to solve for angle A. Like, we all have to solve for the same thing first. The last homework, when we had two angles, so we really knew all three, there was, like, more variance in, like, what you solved for first. It didn't have to be something, but we're all going to have to solve for angle A. So what, 23 over the sine of A? Oh, and I'm going to say, I'm going to mark this down as my first triangle. Okay. Because, of course, when I'm looking at this, I have side, side, angle. Bad word. I'm going to assume there are two. So I'm going to call this my first triangle. Okay, well, I would solve by cross multiplying, right? I'm going to sort of shortcut a little and say that the sine of A is equal to 23 times the sine of 33 all over 14. And what will you have to do to actually solve for angle A? That will be the sine of A. How will you get angle A? In your calculator, how do you undo a sign? Use the inverse sign. Okay. So I can also say that I'm going to go ahead and do inverse sign. So if you want, if you feel comfortable, you can type that all in at once. Okay, again, make sure your calculator is in degree mode here. So pay attention to your parentheses if you need to close them. I'm getting, and see if you can agree with this, angle A is 63.48 degrees. Let me know if you don't get that. If you don't want to type it in all at once, you can do 23 sine 33 divided by 14, hit enter, and then do second sine, second negative or whatever to get your answer. We okay? All right, so if we know that angle A in there is 63.48, now we can solve for what? Pretty nicely. The third angle, right? Now we know two angles, so let's find the third angle. So I'm going to solve for C. C equals 180 minus 33, the angle that I knew originally, minus 63.48, the angle that I found. So 180 minus 33 minus 63.48, that gives me 83.52. Okay, And then I can now find side C because I know angle C. So far the math is letting me do everything, right? I haven't come up with anything strange. So I'm assuming this triangle is actually existing. Okay, because I can find the next angle. Everything makes sense. Things that don't make sense, errors in your calculator, negative side lengths, negative angles, those things would make me think twice about what I was doing. Okay, so I'm going to set up 14 over sine 33 equals C over sine 83.52. So C equals 14 sine 83.52 divided by the sine of 33. I'm getting 25.54. So equals C right over here. So without too much issue, I found a triangle. At least one triangle exists for this ambiguous case. I might check my angles and sides. Remember, that's always a good idea. So I think my biggest angle was angle C, 83.52. And it is across from my largest side. 25.54 is my largest side. My medium angle was angle A, 63.48, and it's across from my medium side, 23. And my smallest angle, 33, is across from my smallest side, so I'm feeling pretty good about that. Are we okay so far? Okay. Now I'm going to say, because this was a bad word, I know this is a bad case. This is the ambiguous case, side-side angle. So I always have to remember that when I have two sides in a given angle and I'm not using law of sines. I'm going to attempt a second triangle. Okay, and here's where we have to be thoughtful. So remember back when I said, what are you going to solve for first? And we really had no options, right? The only thing we could solve for is angle A. So that would still be true because I still have the same given information. B is 33, A is 23, and B is 14. But do you remember when I was showing you that example on the GeoGebra and I got the two triangles to work? I said I would classify one as an acute triangle. The other one was an obtuse triangle. And the way that we can say that those two angles are related is that acute angle and the obtuse angle that was changing, they're supplements. So they're supplementary. They add up to 180. So again, we would only be able to solve for A, but the calculator is going to give us, when we do inverse sine, remember how inverse only goes from negative 90 to 90, the first quadrant and the fourth quadrant, that half moon? It only gives us acute angles. It never, ever gives us an acute or an obtuse angle when we do inverse sine. So what if A was really obtuse? Then we could just use this almost like a reference angle and subtract this from 180. So if you want to search for a second triangle, you just go back to the very first angle that you found. That's the only thing you could have found, right? And instead of saying that it's acute, which is what the calculator is always going to give you, find the obtuse version of that. So do 180 minus 63.48. A would be, if it were obtuse, if this triangle actually does exist, A would be the supplement to 63.48. Okay, so that's how you're always going to start searching for that second triangle. Now, it won't always be angle A. It will always be the first angle you found. So it's not the given angle, like B was 33. Don't do 180 minus 33. B is fixed at 33. It cannot be obtuse. It is that first angle that you solved for. So you do the supplement for that. Okay. And now, just continue on your merry way. After we found A, then we found angle C. So if C exists, it would be 180 minus 33 and minus this new angle A. Like, what if angle A was actually an obtuse angle? Does angle C exist? Minus 33 minus 116.52, 30.48. Seems like a reasonable value for an angle. I have no reason to question it. I got a new A, the supplement. I got a new C, just using like the fact that they have to add up to 180. And now I'll search for my new side C, right? Same setup, but a different angle for C. So that would be like 14 over sine 33 equals C over the sine of 30.48 now. So C equals 14 times the sine of 30.48 divided by sine 33. We'll see what happens. I get 13.04. At any point your calculator is not agreeing with me, let me know. In case I make a typo. In case we have some issues on our calculators. Well, again, so far, nothing has really stood out to me that I should have stopped that didn't make sense. I can do that double check at the end. Now C is my smallest angle, right? Because it's less than 33. And then 13 is the smallest side because B is 14. So then medium to medium. And then, of course, A was my largest angle and side A is my largest side. So it still agrees with long to large, small to short, that kind of thing. So I think this is the ambiguous case of two triangles. I don't know what you have to do for yourself in your notes right now to tell yourself to check this. I think the silly little thing about the bad word can be really helpful. But obviously you're going to be taking quizzes and tests. You're going to be I gotta finish the problem and then I gotta move on. And it's gonna be so easy once you do one triangle to just go on to the next problem, right? And then of course you're gonna be missing half credit because you won't have found your second triangle. So what can you do to say to yourself that makes you think about law of sines and checking ambiguous case? If you're doing the law of sines and you started with two angles, you're okay. You don't need to check the ambiguous case. Do not do any extra work for that. Okay? If you're doing the law of sines and you're starting with two sides, then you've got to do ambiguous case. When we do law of cosines, there is no ambiguous case. So we won't have to worry about it. There's only one case that's ambiguous, side-side angle. Okay. Questions so far? Are we all okay with how I got my new angle A up there? Okay, angle A's, or the first angle you find, it's always the supplements of each other. All right, example 2. I'll let you guys solve. Let me know if you're having any questions with your calculator. If you need an idea of where to start. This is going to be angle B is 79 degrees, side B is 16, and side C is 9. Yeah. to check its mode. I don't know if they've all been used yet or not. Now just looking at the things provided, I know it's two sides and an angle. So I guess I'm kind of deciding between side angle side or side side angle. If you draw out the triangle, you'll be able to see pretty clearly it's a side side angle. Because the angle is not in between the two sides. So that's going to be a warning to you on your quiz on Thursday, on your test in Chapter 6 after spring break. Check for that second triangle. Assume 2. Assume the most work. Let's see, everybody should have started by solving for angle C. There was only one option, right? That's the thing about ambiguous cases. Everybody's got to solve for the same thing right off the bat. I got 33.5. Let me know if you don't get that. Okay, so I solved out my first triangle. Everything seems to be going really well, right? Angle C is 33.5. Then I know 33.5 and 79, so my third angle must be 67.5. And when I plug that in, I get A equals 15.1. If you go back and you compare, 79 was your largest angle, and it was opposite of 16, which was the largest side. C was your smallest angle. It's across from your smallest side, 9. And then the A's are the mediums. So everything seems to be going well. Does anybody have any questions about solving for your first triangle? Okay, so remember, you got to pay attention somehow, and I don't know what you have to tell yourself to do this. Okay, but you'll pay attention to this. It was side-side angle. We don't know if that setup is such that my third side could actually form two triangles. So I am going to assume that there is a second triangle. And what am I going to solve for first in my second triangle? angle C, because that's really the only thing I can solve for with the given information. But we're gonna use what for C? The obtuse angle. So we're going to say, what if it was not 33.5? What if that was just the answer the calculator gave me as a reference angle? And this is really an obtuse angle. So then I would do 180 minus 33.5. So what is that? 146.5? Okay, so what if angle C was 146.5? Anybody got any statements to make? Yes?
How do you know to start with C?
Because it's kind of like you're going back to the original problem, right? Like this stuff right here that you know. So you would essentially you have that triangle ABC that I have over on the side, and maybe you're thinking about it like I'm restarting the problem. But if those are the three given pieces of information, by law of sines, the only thing you can solve for is angle C. Because you have the B across from side B, and then you have side C. So the only two ratios that you can use are the ratios for the B's and the C's. But we're just saying, someone over here was saying, what if it was the obtuse angle? So then we find the supplement. We would do the same exact setup, and we'd really be getting the same exact answer. The calculator, remember with inverse sine, it will only answer in quadrants 1 and quadrant 4, and ours is always going to be answering in quadrant 1, giving us positive angles right there, but that doesn't mean that there couldn't be an obtuse angle. So then you're treating it what if it was the reference angle over here. Any other statements you want to make? Now that we found C, Evan?
Well, the angle for C is bigger than the angle for B, but the side C is smaller than the side B.
Oh, so you're comparing side lengths and angle? So this is our biggest angle now because it's obtuse. And now it's going to be across from side that is 9, which is not our largest side. Could that really be a triangle? No. Anybody else find out there wasn't a second triangle another way? Trevor?
When I solved for angle A, it was negative.
Some people might go forward and solve for angle A, but if angle C is 146.5 and angle B is fixed at 79, you're over 180. So it doesn't make sense. There is no triangle. No second triangle exists. Okay. Angle A would be negative. Or small side across from large angle, like Evan said. Either one of those is a bad deal, right? So no second triangle exists. This one, if you continue with the math, I like what Trevor said, is that he'll get a negative angle for A, and it doesn't make sense for A in a triangle to be negative. So if you are unsure when to stop, when there isn't a triangle or there isn't a second triangle, well, just try doing the math, and the math will not make sense. Okay? It will be no good. Okay? So we've done 2 triangles, we've done 1 triangle, and we have yet to see 0 triangles. So here's going to be our 0 triangle, not to spoil it. So let's say angle C is 85, side A is 25, and side C is 15. See if you can solve that triangle. What's that? Got an error. Did anybody do 25 sine 85 and divide by 15 and like see the number?
Yeah.
What is it?
1.66.
1.66? Something. So I'll put dot dot dot. Get inverse sine 1.66. We've had this conversation before, right? Sine is supposed to be opposite over hypotenuse. The hypotenuse is supposed to be the longest side of a right triangle. It wouldn't make sense for the opposite to be larger than the hypotenuse and get a ratio of over 1. So you have a domain issue with the inverse sine. You can't put in ratios more than 1 or less than -1. It's telling you error, so then we know there is no triangle. Now maybe look at the values similarly sort of to like what Evan did on the last one when he had solved, once we had solved for angle C as an obtuse angle. When I draw this triangle out and I put in those angles, I notice that angle C is 85 and it's across from 15. And then side A is supposed to be 25, which is actually like a fair amount larger than C, right? And in order for that to be true, then angle A would have to be more than 85, and there just isn't a lot of angle degree left over, considering that we have to get 2 more angles in there. Is it possible sometimes that longer side that you could actually solve? Yeah, it could be like that one where we saw like the really skinny triangle, the really slim one. Sure, it is possible, but we can also kind of say like it does seem like that maybe this side is too long and that I wouldn't be able to actually close the triangle, okay, with the angle that I have. Does that make sense? Okay, so take a moment right now to think about to yourself, what are you doing at the beginning of a problem, okay, so that you recognize ambiguous case? And the only time you ever have to check for a second triangle is ambiguous case, side angle. Okay, when we're doing law of sines, angle, side angle, angle, side, or we're doing law of cosines, we do not have an ambiguous case. You never have to check for a second triangle. Okay, so we've got maybe a little less than 10 minutes, but that's a fair amount to get started. You know, maybe 1 or 2 of your homework assignments will be no triangles. That will always be nice. This should be on your gold sheet. I just want to put out a reminder about Chapter 5 test retakes. The deadline is next Thursday. Not this Thursday, but the following Thursday, the one right before spring break. If you want to do a retake, make sure, like, check your homework grade. You have to have all the homework completed, or it would have had to have been completed before you took the test. If you didn't do your Chapter 5 homework, then you have that grade, and that is yours to keep. You'll need to check out the test from me, so you can do that today or any time this week, and you do corrections. I would say on Chapter 5, probably a separate sheet of paper is good for your corrections because you probably have a lot of, like, stuff written out. The 10-question assignment is still up over on the sideboard, and you have to do both of those before you take the retake. So if you tell me that you're planning to come in like this Thursday morning and you show up at 7 and you don't turn in the test corrections in the 10-question assignment, then you don't get to take the retake. So just make sure that you are completing those things if you're planning the retake. And then the retake forms are the pink forms in the purple folder over there. Just grab one, fill out the questions that apply to you in honors pre-calculus and test retake. And I will say the sooner you talk to me, the better, because I'm not available every single day before and after school for the amount of time that would be required for the retake. So we have to like put our schedules together and make sure that we're both available at the same time. Okay, so if you're doing a retake, make sure that you talk to me.